So, hello and welcome back to my C++ tutorial playlist. In this video I want to cover the standard template library, and the standard template library is concerned with two things, which are containers and algorithms. And the really cool thing in C++ in the library design is that both of these things are completely separated. You can have containers like a vector, which is basically an array that can grow in size dynamically. And of course, we also have a standard array and other things such as sets and many other ones. Here is a really good overview of how to choose the container that you want to use. I will also provide this on my website. I found this is not made by me, I found this on GitHub. I unfortunately forgot where exactly it came from, but you basically start here. Is the order of the data in your container important? If, let's say, it is important, then the last data that we put into our container is the first thing we want to access again. Then we want to use a stack. Then you can work through these. Let's say we don't know in which order we want to access the items, then we get into here. Then we can decide if it's important for us to have our elements sorted. If it's important for us, then we go here. Then what's the main purpose? Do we want to iterate over our data frequently? Then we need to use a vector. Otherwise, if we want to have lookup keys, for example, like in a database where we don't iterate over all the entries, but we want to look up certain elements, then we maybe want to allow duplication. Basically, this is how you decide on a data structure. Usually, if we don't need a container to grow in size, then here I would prefer to use an array, but a vector is really a good default container. It's not that performant, but it also doesn't hurt too much. But just keep this in mind. Also because vectors allocate heap memory, you really need to keep this in mind that this might not be the best option. And if you decide to use the vector, also think about how big the vector will get. So you can maybe pre-allocate some memory with reserve. And then we also have algorithms, which are in the algorithm header. And the cool thing is, this design lets us use any algorithm that is defined in the algorithm header with any container that has some basic functionality. This allows us to write our own containers and use the standard algorithms, or write our own algorithms and use any of the standard containers. So this design is really ingenious, and I really like it because for me in university we learned to write, for example, a queue and then have all the algorithms, all the actions we can do on the queue as member functions. But this is of course not really scalable because we would need to, for example, if you want to sort a queue, then we would have to write the sort algorithm for the queue, and then we need to write the sort algorithm for an array if we implemented an array class, and so on and so forth. And here in C++, for example, when we have a vector, for example, let's create a standard vector of int, and let's just call this test and fill it with some data, something like this. Then we have our sort in the algorithm header, and as we can see, we just need to provide a first and the last iterator, and any container that can provide these iterators can be sorted with just calling sort. So we just provide test begin, test end, and you might already see that this design is really cool, and we can write very complex algorithms by just making use of the standard algorithm and making compositions of that and chaining them together to display that everything worked. We can also, of course, print everything out again. And then when we print our test vector here, then we can see that everything is sorted. So here I have a quick overview of all the standard library algorithms. This image has been taken from hackingcpp.com, but it really explains all the most common algorithms. And as we can see, we have an overview here and also see how the algorithms work. Please look over these on your own. I think they are very well explained. And as you can see, most of them require a begin iterator and an end iterator that we can get from our data structure or our container. I just found this overview to be really helpful. So please check it out and also visit hackingcpp.com. They have really great cheat sheets. And to take this one step further, I want to write a small data container to show you maybe some use cases of the standard library and where it comes in handy and what not. So first of all, I want to create a class, data manager, and we want to be able to add data here, and it should be of any type. So we can use any type here, basically. Any is also a container from the STL that can contain different data types, and we also need to be able to store them. So we create a private data container, which is a vector of std any, and we call that data underscore, or maybe data underscore, and then we can push back our value. And we don't need to be concerned with any memory allocations or the size of the value or anything. Any already handles everything of that for us, and we don't need to be concerned with that. Then we also want to be able to display our values, and where we already have included print. So let's use print. And here, okay, this. And we want to iterate over every element in our data that we've stored in our class. Okay, we might need to write a small helper function here. And write it here. And here we can have if else. And here we can check for the type. And if it's integer, then we can print it here as an integer. And we can continue this for all the other types that we want to be able to handle. For example, double, also for string, for example. And you can add on any types that you want to handle here. Let's just leave it for now like this. And otherwise we want to print unknown type. So we know that something went wrong, like so. Also, what we can do is we can remove data based on a type. So let's call this remove by type, for example. We will remove any data from the data of that type that we just received. And we can use erase function of vector here. And here is another algorithm. We can use remove if, which also requires begin iterator and an end iterator. And then it requires a predicate, and that is basically a function, here in our case a lambda function, that tells us if this item should be removed or not. So it needs to return that, and the item should be removed if its type is equal to the type that we provided. And then we have our first, and that is decided by the remove if, and here we can see that the remove if also returns an iterator to the end of the resulting sequence. So we can use that as our first iterator of our erase, and the last iterator is of course the end of our data. And then also we want to expose, basically we want to write a wrapper around an STD algorithm to find elements in the data. And for that we will return a copy of any data that as a vector, of any elements as a vector that we found. And we call this find if, and it takes in the predicate, and we annotate it as const because we don't want to modify our data container. Here we create a vector for the results we want to return. And here we can use the copy if that copies data into a new container based on a predicate. And here we provide the data structure that we want to insert into, and then the predicate that decides if the data should be copied or into the new container or not. And then finally, once the data that have been found has been copied over, we want to return the result, like so. And as you can see, you can get really creative here. This is just a toy example. To use our data manager, we first need to create a data manager, and we can then add data to it of basically any kind. We should probably encapsulate this into a string to make sure it can get displayed correctly, because you've seen here we only handle these 3 cases. It's either double, an integer, or a string. So double is still missing, so let's add double value. And then we can display all the values that we have in here. Then we can also maybe use the find if. So manager find if, and then we need to provide a predicate, and we need to return a boolean. And here we can get really fancy to find any integer, for example. That would find any integer. And then we also want to require that the integer is greater than 50. As you can see, we can query this data now, like basically in a database, for example. Of course, we can also print our result. And we know that it has to be an integer, so we can cast it to an integer. And this should display our 99. And also we can remove data from the data manager. So let's say we want to remove any integers, and then we want to display all the data again, like that. So should just be a small demonstration of what you can do with the standard template library. We can build really complex managers and algorithms and so on, and data containers, by just making compositions of the containers and algorithms that already are provided to us by the STL. Thank you very much for watching, and with that, see you next time.